Oh, awesome. And we're going to put this on my YouTube channel. Just make the link available to everybody. So, good day. Thanks for joining us. My name is Lawrence Lockhart. Today, we're going to talk about a history of JavaScript. And so, I'm calling this a trip down memory lane, or an introduction to the web for noobs. I could have also called it an introduction to the web for all those that the web was already here when you got here. I'm a little bit older than that, so I actually had the benefit of seeing the web come along from its infancy to where it is today. And it's really neat, the position that we're in as web developers, software engineers, so many different disciplines. Where we live right now is a level of numerous abstractions beyond the metal, right? We're beyond that base layer. And there's a lot of things that went to create what we get to enjoy today. And sometimes, this is not all the time, but sometimes, even as a self-taught developer and a person that works with a lot of other self-taught developers, sometimes we don't even have the time to appreciate from whence the technologies come. We know from where we've come, right? I've got 17 years in the restaurant industry, slaving away, flipping burgers and managing people and dealing with angry customers. I know where I've come from, but sometimes we don't necessarily have the appreciation for where the technology has come from because it's really gone through a lot. So obligatory about me, that's how you got to start a talk, right? My name is Lawrence Lockhart. I'm a full stack developer at FedEx. Been there right at 1.5 years. Big part of my story is, yes, I'm a midlife career transition, self-taught person. I spent 5 years in supply chain, 17 years in the restaurant industry. So that's 22 years in other things. And honest to goodness, just reached a point where I had enough, pretty much ready to tell my boss, take this job and shove it. Y'all know the routine. And so I didn't do that because you don't burn bridges. But I did begin learning and going through every possible resource I could get my hands on to learn more about this technology thing. I was always kind of supposed to be here, but my actions and my mind didn't go together. And so I don't want to say wasted away a lot of youth or a lot of my youthful years. I learned and had great experiences that actually benefit me now, but I wasn't in tech until here just recently. And so because a lot of people poured into me and helped me, I have made it my life's passion, my God, my core to help as many others, to contribute to as many other people as humanly possible, because so many helped me make this transition. And so you see right there, I love helping people learn to code. I am a husband. My wife's name is Joy, born on Christmas Day, and she is quite a joy. I'm a father of 3, and I'm a dog owner. And of course, when you mention your dog in a talk, you have to show your dog. So there's my dog, Lucky, little blonde lab, cutest dog ever. All right, so JavaScript, where did it actually come from? Where did we get JavaScript from? So to understand a little bit about JavaScript, you have to understand this thing called NETSCAPE Communications Corporation. This is a company way back in the day. NETSCAPE Communications Corporation was founded by Jim Clark, Mark Andreessen, Kleiner Perkins. I want to kind of highlight Mark Andreessen for just a minute because this is the guy who, when he was at a former institution he used to work at called NCSA, he had a vision for what browsers could do far beyond what they had at NCSA, and he felt kind of constrained, kind of confined. So he broke off and said, hey, we're going to do our own thing. And as was the case very often in those days, he left and he took like some of the best people with him, and many people came along thereafter to join him on this new mission. So again, they used to work at NCSA. The browser at that time, 91, 92, is called Mosaic. They break off and start a company called Mosaic Netscape, all right? And Mosaic Netscape, the browser that they formed there, eventually they renamed it to just Netscape Navigator. Those of you who are my age, I'm mid-40s, well, late 40s, whatever. You may remember Netscape Navigator back in the day. It used to be the thing, right? Before IE really exploded and all the others. It was Netscape Navigator. But at the same time, at this other place, you had NCSA Mosaic. So you had these two browsers, and this is actually the original browser wars. Now, when you think about browser wars, you're thinking Chrome versus Firefox, Firefox versus IE versus Opera, all these different ones that we have today. But originally, it was, as far as commercially available, just two. These two right here, Netscape Navigator, which was created by the people that made the one that they were going to competition against, NCSA Mosaic. So let's dig a little bit deeper. Because to understand all this, Mosaic, I've said that was started at NCSA. That stands for National Supercomputing Applications, National Center for Supercomputing Applications. It was a research center. It wasn't even a company per se. It was a research center, a think tank, if you will, at a university, University of Illinois, Urbana-Champaign. And I want to take a pause right there because I had some conversations with some friends, other associates, folks on YouTube and things about this whole CS degree versus non-CS degree thing. And too often the right question isn't being asked. So it is absolutely true, due to the number of abstractions we have, how far we are from the metal, it is totally possible to enter a number of tech fields without a computer science degree. That does not negate the benefit and the value that there is in computer science and in software engineering, because computer science is a science. Software engineering is an engineering discipline. And quite often, the technologies that we enjoy today are started on university campuses in the numerous research centers that they have. The money's getting poured into them, and then they proliferate out into industry. That is the normal pattern. And when you get deep down into it, you're talking about making, hey, so many of us are working on video editing and gaming. We love our awesome chip, right? Where do you get the theory for how to build a better chip, right? That goes way beyond, what we're doing with JavaScript or anything in the web. These are sciences and disciplines. So there will always be value in computer science as a science, always be value in engineering as a discipline. And there's also amazing opportunities for us as self-taught folks to come in and use some of the languages and some of the technologies that are built on top of that to build amazing things. So this original group is at the NCSA. They have the first commercially available browser called Mosaic, 1991. And that didn't even come in a vacuum, because in order to do that, they actually got some legs behind it. They got a little thrust from a congressional act called the High Performance Computing Communication Act of 1991. I don't know why they named those things so long, but whatever. This was a congressional act that was passed in 91, probably before some of you were even born, and it did two very important things. The first thing it did, it called for the formation of a national information infrastructure. Many of you might know that as the information superhighway. The people, the Congress people at that time wanted to see the digital documents that were stored at various research centers all around the country, email servers, research center servers. They wanted to see those documents connected in an electronic way and accessible to the public. It was a specifically United States thing, kind of like the race to the moon. They wanted to be the first to really connect the documents, the information of the electronic servers at that time that were individual servers on individual institutions. So they called for that. And to make it happen, they also threw $600 million in funding at it. Now, today, that's maybe not a lot of money. We're talking in terms of trillions these days. In 1991, to ask for $600 million for something that to the large degree was still theoretical was a ton of money. But it went through, and to have that kind of money go through, to have that kind of an act go through, it really took a super visionary person. And so I wish we were in person. I could see the faces. I could ask the question, who knows this guy? Right? If you don't know his face, you should definitely know his name. Let's just talk about him for a little bit. This person was a representative. I think my window might be covering up some of that. He was a representative. He was a senator from Tennessee. He was vice president under Bill Clinton. Back, if you remember the whole thing, he ran for president after that in 2000. Big issue with the Electoral College and the hanging chads in Florida. No resemblance to anything going on today. This guy won a Nobel Peace Prize, an Emmy, a Grammy. He's a visiting professor at numerous universities. He's an acclaimed environmentalist. Pretty much he's an overachieving nerd, like just a visionary like that. But this was important because at that time, 91, this is internet infancy. People don't really understand what this can do, what the capabilities are. Is it dangerous? Should we be leaving this alone? Right? Is this satanic? I mean, all kinds of things are floating around. But this is the guy that really advanced the thought we need to connect our computing resources. And his name, of course, is Al Gore. Now, unfortunately, Al Gore is often known as the guy that made the quote, "I invented the internet," which was taken out of context, but he absolutely did not invent the internet. All right, he had a great vision. He pushed forward the Congressional Act. He did not invent the internet. However, this guy right here, of course, my phone would beep right now. Sorry about that. This guy right here, hopefully if you don't know his face, once again, you know his name. He is a luminary in this space. Talk about him for just a minute. Do you know the web? Are you a web developer, front end, back end? Do you do anything with the web? Do you surf the web, email, any of that? This is the guy you need to be looking at. This is the guy you need to know a little bit, at least a little bit about his history. His name is Sir Tim Berners-Lee. His name is Tim Berners-Lee. He was knighted as a Sir by the Queen for the amazing work that he did in electronics engineering, in software engineering. He advanced technology to a place where it had never been, and he was knighted for those efforts. So what did he do? He worked at CERN. Who's heard of CERN? I can't see y'all, but who's heard of CERN? CERN is an amazing physics laboratory out in Sweden, close to Geneva. CERN is known for the Hadron Collider. They spin atoms and protons in circles. faster and faster, and they collide them to get an idea of what creation was like shortly after the creation of the universe. They split these atoms, they split these protons, and his work there generated a number of documents. And the time he was working there, 1989, 1990, they had computer servers, and they would store those servers on those documents on those servers. Now, at the time, let's say you worked at a physics institute in Memphis or in California or wherever, and you wanted access. There was a very, oh my God, arcane, hard, slow way to electronically access the server and then access the documents of the documentation of what they were working on there at CERN. You would better just be waiting for it to come out in Popular Mechanics magazine. It was very hard to do. Even more so, again, this is a research institution, not so much a company. CERN is a research institution, and he's a physicist. The documents that they worked on, when you produce a document, all right, all of you have done research papers, right? You remember back in the day when we would do research papers, you had to have footnotes and a bibliography. What was the purpose of that besides getting an A? You have a bibliography to a paper, a research paper, a white paper, so that if you write the paper and let's say I access your paper and I want to have some idea, where are the source documents that you got this from? Maybe you talked about one particular part of this paper that intrigues me and I want to dig deeper. Well, if I go to the bibliography and the footnotes and I connect those, I can then go and see where you got your information from. Beyond the original research that you did on your own or the experiments you did on your own, I can see some of the background research that led up to where you are, right? And I'll go to the library and I'll check out the book and all that stuff. Well, Tim said, why can't we do that electronically? If I have an electronic document on my server here at CERN, and someone at a physics lab in MIT gets my document and they want to know where I got my base knowledge from, how do they access that? How do they link back to that? We don't have a way. And so he went to work. He did a fancy diagram. I should probably have it here in the presentation. Sorry about that. And he went to his boss and he said, hey, I want to work on this thing. I want to have a way to link resources to the resources that generated them, or the resource that generated them. I want to be able to link these things together. And his boss was like, meh. He gave him the cold shoulder. He wasn't really feeling it. But you know, this was Tim's passion. He kept going back. And the boss was like, yeah, this is exciting, but vague. Again, this is pre-internet as we know it today. So even the person he reported to didn't get the vision, but Tim had his own vision. Kept going back, eventually got approval to work on this particular thing. Now, I got to take a pause right here. I think I am a productive person. I'm very busy. I'm involved in a lot of organizations, do a lot of things. I don't have a lot of free time. Usually when I do have free time, it's that I've actually penciled in free time. That's the kind of life that I live. I thought I was a busy person until I read up on Tim Berners-Lee. This guy got busy. I mean it just like that. HTML5, we all should know HTML5, right? The markup language, the basics of the structure of the web or structure of a website. We are on HTML5 right now. He wrote HTML1. All right, he invented HTML. There was no HTML before that. He invented HTML1. That's this guy. Hypertext markup language. Why? Because he needed a language that he could use simple markup on, just like you turn in an English paper and your English teacher gives it back to you with a little markup on it to show you, oh, this should be bold and this should have been a period. He wanted to put small markup language, markup on an electronic document where it could use hypertext. Hypertext had actually been around 10, 20 years before this, but it never been used in this way. He wanted to use the technology of hypertext and put that inside of a language where if I access your research document, I can simply click on a string and hypertext would send me to the resource where your research came from. It would create literally a link. And so the physicists at MIT could access the documents at CERN. CERN may have done some research from Georgia Tech. They put that in their document. You click on it, you can see the research, and all of these research institutions began to be connected. He invented HTML. Now, wherever you go, wherever you're going to make that request from, it has to have some sort of an address in a string format that HTML will recognize. So not only did he invent HTML, he invented URI, Uniform Resource Indicator. I'm telling you, this guy was busy. Didn't stop there. He also gave us HTTP, Hypertext Transfer Protocol. So we have a set of standards behind how all this communication is going to work. This guy, I'm telling you, he's the guy. And it's crazy that we don't know more of his name. He wasn't finished there. He gave us worldwideweb.app, the first interactive, commercially available web browser. There were browsers before that, but they were very, I mean, they were just arcane, static. You wouldn't want to use them. He gave a commercially available dynamic website called worldwideweb.app, and he gave us HTTPD, which was the first commercially available web server. All right. And he wasn't done there. The first commercially available website was also made by Tim Berners-Lee. So if you don't know that name before now, I hope you know it and remember it forever, because he gave us HTML, URI, we usually say URL, HTTP, the first web server, the first website, and the first interactive browser. Couple of things in the chat. All right, no problem, Ramon. Thanks for popping in. Awesome. All right, so that's what he did. What else? I don't want to mention that part just yet. So before the work that Tim did, this was your web experience. And it looks a lot like email. It looks like that for a reason, because it was basically you logging into your, let's say I'm at Georgia Tech. I'm gonna go log into my computer system. I literally make a request, almost just like an email with a header and a body. And based on the way I structure that request, typically the header was ignored, but if I send it to the right address, the server that I sent it to will respond with the document that I want. And in this case, this was like a sample of a bunch of recipes where people are making a request. I want this recipe, and the server would send it back. Very static, but even for this time, this was amazing. But Tim said we could do better. He had a personal passion. He said, I can do better. And so Tim is the guy that took us from this to that. Now that looks very recognizable in terms of the web. It's kind of plain. There's not a lot of pictures and stuff bouncing around, but you recognize that. It's written in HTML. Of course, he gave it to us. Look at that website name, info.cern.ch. I told you he worked at CERN. That was the whole purpose of the web for him, was to get their documents out. That site is still live. You can look at it today. It's kind of like a web museum. A couple of things that are cute, kind of neat on this page. The very first line, I love it. The World Wide Web, the way he envisioned the World Wide Web, it was a wide area, hypermedia information retrieval initiative. That's what he wanted to build. A wide area, geographically, hypermedia, we talked about hypertext, information retrieval initiative. From that, you get TikTok. Seriously, that's the thing that built TikTok right there. I love the next line too. This is mind-boggling when you think about it today. At this time, everything there is online about the World Wide Web, everything about it was linked directly or indirectly to this one document. That is mind-blowing. There are very few documents you can say about that today. In a sense, that's kind of Google's mission when when Google was formed by the two. They wanted to connect the world's resources. He was doing this at the instance, or the instantation, if you will, of the web itself. There was one more on here that always gets me, the bibliography. Like, this website had a bibliography. Like, it would be like to go to ESPN.com today, scroll to the bottom, there's a bibliography. You would never see that. But it totally made sense in this era, 91, 92, because it was about the research documents and the resources that made those documents. So of course they had a bibliography. Tim still wasn't done because, free time, right? So after he does all that, he releases the source code to his browser as well as to HTML. He releases it to the public in 1993, kind of lets that be an open source project for the world, which is also revolutionary at the time. Leaves there, goes on to MIT to form the World Wide Web Consortium. You call it W3C. All of that was started by Sir Tim Berners-Lee. I've got two computers going here, so y'all be patient with me. This is just a weird picture. I just put it off the internet. It's like a Thanos-inspired atlas, but in my mind, right, the nerd me, like, this is Tim Berners-Lee at this time. You've got the web, you've got HTML, URIs, web servers, all of this stuff in your head and in your hands, and you're just kind of balancing it, and then you're presenting it to the world like, here's this thing. So I thought that was pretty cool. Oftentimes our images of our technicians are very weakened for whatever reason. This is a very strong image. I think this is a great image of Sir Tim Berners-Lee, in my opinion. And the fact that he kept going back to his boss, even though his boss didn't necessarily believe in the vision, originally gave me this thought that I'm carrying with me for the rest of my life. The fact is, sometimes believing in your own passions is tantamount to succeeding in the next big thing. It's not always about finding what is the hottest language for 2021, what is the biggest startup that's going to blow up in 2022, what's the first framework I should learn. Sometimes you need to look more so within. Trust that you know things, you have experiences that are valuable, and even if people give you feedback that's initially negative, don't be afraid to hold on to your passions. It could be tantamount, synonymous with succeeding in the next big thing. So back to Netscape. I left them kind of in the lurch. Netscape's first product was Mosaic Netscape, ends up becoming Netscape Navigator, 93, 95. But it was still, so this is a little bit after Tim, right? He was 91, 92, they're 93 through 95, but they're still kind of static. It's kind of a boring experience. Then there's people there, Mark Andreessen and the boys, they have this vision that there can be some more animations, there can be some interaction, there can be some automation that is part of the web. How do we enhance the experience? We need some more interaction with the elements on the browser that we call the DOM. What are we going to do? And so, again, this is just a quick little chart. Don't worry about all the information on here, but this is what's called the internet boom. There was a thing called the internet boom, the rise and fall of that. You see the peak there was 2000, but I want you to look at just the dates. The first date they have there, 1995. So this is 93, 94. We are just pre-internet boom, right? We are just pre all this stuff blowing up. I love the quote by Alan Greenspan down there on the bottom. You see that December 5th, 1996, Alan Greenspan warns of a irrational exuberance. He wasn't all about, all this money being thrown at all these startups. He's like, y'all need to calm down on this internet stuff. I'm glad we didn't listen to him, right? But this time period that I'm talking about, 92, 93, 94, we are just pre-internet boom, which means it hasn't taken off yet, but the scientists, the engineers, the developers, they had a vision that this thing could be huge. It just needed a few more key pieces and a few more key players. Enter this guy. Who is this guy? You need to know this guy. If you're in the web in any sort of way, you should know this guy. His name is Java. I'm just kidding. His name is not Java. I'm sorry. His name is not Java. This is James Gosling. He wrote Java. This is the guy that invented Java when he was working at Sun Microsystems way back in the day, 92, 93, 94. The language was originally called Oak because he sat at a window and outside was a beautiful oak tree that he liked. So he named the language Oak. That didn't stick. They renamed it to Green. That didn't stick. And then they renamed it to Java because I guess all programmers drink coffee or some derivative thereof. So they thought. Java was made to do a lot of awesome things. And I got some notes here. It was designed to write once, run anywhere. It is kind of a big, bulky, enterprisey, verbose kind of language, which turns some people off, right? It is statically typed. We don't have any of that implicit typing going on. The first version comes out, Java 1.0 comes out in 1994. They have another version that they have planned to release for 95. James is overseeing this whole process. It was actually released, the next version was released at the Sun World Conference in 1995. So he releases Java, and these guys, Netscape, find out about the things that Java could do. And they said, that's it. We want some Java. We want some Java in our next browser. We got Netscape out there, but it's kind of boring. It's static. It's not really just capturing people the way we want it to. We want some Java to do this heavy lifting and to increase our speed and our security and our durability and scalability. We want some Java. So Netscape starts interacting with Sun Microsystems to pull off this deal. But at the same time, the engineers are looking at the language and they're saying, what about our hobbyists? What about the amateurs? What about our designers? What is the likelihood that a self-taught, well, they didn't even call it self-taught at the time, but what is the likelihood that a hobbyist is going to pick up our browser and just want to up and start learning Java, like with no computer science background? Not very likely. So they said, what we need is Java to do the heavy lifting, because everything was written in C pretty much at that time. But we want Java as that enterprise, as that undergirding hardcore language, but we want something else, kind of like a Java Lite, to like dance on top, to be like Java, but not Java, to be a little less verbose, a little easier to understand and manipulate, something that will help to proliferate our browser and increase the market share of our browser. So yes to Java, but we need something else. We want them to kind of pair together. And that was not altogether that abnormal. At the time you had, like I said, C was just prevalent in everything, including browsers. And in many cases, you would have C as that more enterprisey undergirding language. And then you had Microsoft Visual Studio that kind of floating on top, a lot more easy, a little kind of drag and droppy, a lot easier to use. But when you have things easier to use, more of the public will get into it. Very important. So that's what they're doing. Netscape got a lot of stuff going on. They got a browser out there. They're going okay, but they want to blow up. We're pre-internet boom. They're working on a deal with Sun Microsystems. to get Java in their browser, which they did, and they want another language. And they start asking people, and they reach out to this guy. Now, up to now, I've been quizzing you, so I'm not going to quiz you on this one. His name is Brendan Ike, and that first bullet point right there, that's the one that all of us has read. Like everybody that ever does anything in the web, you've all read that line. JavaScript was written in 10 days by Brendan Ike. JavaScript was written in 10 days by Brendan Ike. We all know that. But did you do a step further in your research to find out, but why was it written in 10 days? Like, what was the point? Like, why so fast? Are you just, you're in a hurry? Well, they were in a hurry because I told you they were working on the deal with Sun Microsystems. Sun Microsystems released Java in early 95. They wanted to have Java and JavaScript in the browser at the same time. They didn't want 2-3 years of JavaScript development and then they have this thing. They wanted to launch all of it. So they didn't have a small incremental improvement in NETSCAPE Navigator. They wanted to have a humongous improvement in NETSCAPE Navigator all at once. The functionality, the scalability, the speed, the interactions. They wanted to blow up their browser with those two key elements, Java and JavaScript. So as you see there, it looks kind of like Java, which is great because most of your engineers are going to be C or Java engineers at that time. They could easily move from Java over to JavaScript. Some of Brandon's preferences were languages like Scheme and Self. So he sprinkled some of that in there. Feel free to research that on your own. And it was integrated into the browser in 95. The Sun deal went down. December 95, they've got an improved NETSCAPE Navigator. The language was originally called Mocha. Again, the coffee references. It switched from Mocha to being LiveScript to kind of highlight the fact that it was so interactive and the browser's like doing things now and it's more fun experience. And then that wasn't kept, so they pulled a little bit of the script and a little bit of the coffee and they called it JavaScript. That's where you get JavaScript from. I'm done. No, I'm just kidding. So here's some Java. This is a sample code of Java. We got a good little class here. We got our main method. We're going to just print out some hello world because that's where we all start, right? That's your first program. We got a try catch method, like it's starting a new instance of a missile silo class, et cetera, et cetera. This is a basic little tiny snippet of Java. And then when you turn that to JavaScript, it looks similar, but we've taken some of the redundancies that they saw at that time or Brandon saw at that time and put that kind of right behind the framework or behind the language. We don't have to type all that every single time. Interestingly, we got classes and TypeScript and things like that, but that's another story. At this time, this was considered to be a massive improvement and it was a language that people would easily adopt. Some of the features of JavaScript. Some of the features of JavaScript include being, and again, I got these two computers, y'all pardon me, include being object-oriented, but it's important to mention the fact it's object-oriented based on being prototype-based, based on the properties and methods of JavaScript. That's what makes it object-oriented. Some people would say, hey, classes and the object-oriented nature of JavaScript is really just syntactic sugar on top of the prototype system. You may have read that phrase before, syntactic sugar. When you read phrases that don't make sense, look them up. I looked up syntactic sugar, like, what does that mean? And what it means is someone has taken the language and said, I don't like how this looks. It just looks ugly. Let me do some things to it so it just looks better. That's like sprinkling sugar on the language. Or, you know what, I understand what's going on here, but logically that doesn't make sense in terms of the larger scope of how this language functions closer to the metal. The logic doesn't make sense. Let me adjust some of the things in the logic of this so it makes more sense. That's called sprinkling sugar on it. So whenever you read the phrase syntactic sugar, that's what we're talking about. They're talking about changing the language to make it more appealing to the developer. And this is how NETSCAPE Navigator looked. Some of y'all remember that. I do. Aging myself, but that's okay. I'm proud of my age. Yeah, we got some interactivity. We got some back buttons and home buttons, and we can insert a URL, a URI into a location. We've got what's new and what's cool. These are buttons that would just give you some preset links and that would fill out that page. So this is NETSCAPE Navigator. You see it's 2.0. So this is the second version. So the first version took them from the inception of the language, of the inception of the company, all the way up to 94. 94, 95, the deal went down with Sun. They got JavaScript and you get a new experience. So you see Sun Microsystem, you see that right in the middle right there with the deal that they did. So exciting times are happening. We are 95 going into 96. JavaScript is blowing up. The NETSCAPE Navigator is blowing up. NETSCAPE is blowing up as a company. Lots of things are happening really, really fast. And the people at NETSCAPE said, we need some standards. We need to kind of get this baby under control. We've got the pure programming aspect, but we want some standardization. We want to have some versions. We need somebody else to put some hands on this. And so they went to the European Computer Manufacturers Association, and they basically said, help, like, we need some help, like, step in here. Give us some standards, give us some versions. And ECMA at the time, they said, all right, cool, this is what we do. And we're already here doing that. We'll do it for your thing called JavaScript, but we're going to standardize it. And so where we have it, it will be called ECMA script. ECMAScript 262 kind of sounds like something very weird, but that was the very first version that they got. Later on, it would be ECMAScript other numbers, and then we would just call it ES for short. And so ES5, ES6, where we are right now, ES Infinity. They manage the ESs. The ES stands for ECMAScript. ECMAScript stands for ECMA stands for the European Computer Manufacturers Association. It is a standardization organization, and they did that thing. So this is important. So they have the standard. ECMA has the standard. NETSCAPE has their implementation of the standard, almost like a dialect. All right. So I'm in Olive Branch, Mississippi. I have a particular dialect. You are where you are. You have a particular dialect. We're all speaking English, hopefully, or not. But anyway, there's dialects on the language. Similarly, with computer languages, there are dialects pending the implementation of where it's used geographically. That's important. So you have to have one organization that holds the standard, and then yes, different other companies, organizations may implement it different ways based on their use case. And that's again important because here we go with these two guys. One of these is really easy for everybody. You know Bill Gates there with the white turtleneck deal. But the other guy, unfortunately, not nearly enough people know, and I'm sad about that because they are totally in tandem. They're totally a pair. You can't have one without the other at this time period. This is Bill Gates and Paul Allen. These guys were old buddies, high school buddies back in Washington State. They loved working on computers together. They would build things together. Paul Allen left high school, went off to college. Bill's still in Washington State. After 2 years of college, Paul Allen felt he knew enough to go ahead and get a job. He got a job as an engineer with Honeywell in Boston, which was kind of strategic because when Bill Gates left high school, he went to Harvard, which is in Cambridge, right across the Charles River from Boston. And they still hung out. They're hanging out. They're working together, computing together, doing side projects. Great clue for all of you who are in any kind of boot camp, any kind of program. Feel free to find a friend, find somebody on a similar thought process, and y'all just build stuff together. Because the things that they built ended up getting them a contract with a company called MITS. Had nothing to do with MIT. It's a company down in New Mexico. They got a contract while Bill was still in college. The contract was formidable. It was awesome. And they were basically writing basic programs for their microcomputers. Contract went off really well. Paul Allen ends up leaving Honeywell, going to work for New Mexico, work there, learn what they were doing for a while, still communicating with Bill back at Harvard. And together they had this vision that, we can do this not only for MITS, we can do this for a lot of companies. As a matter of fact, we can do this building software for microcomputers. We can do this for the whole world. And so Bill Gates is down with the vision. He leaves Harvard like after during his junior year, he left Harvard. Paul Allen leaves MITS. They come together and they said, we're going to make a company and we're about to take over this whole game. We're going to make all the software for all the microcomputers. So their vision was to make software for microcomputers. So they called their company Microsoft with a hyphen at first. And then they dropped the hyphen and it became just Microsoft as you know it today. This is 1975, 21 years before they decided that their Internet Explorer browser, which was totally boring and arcane at the time, needed some of the fun stuff that they saw over with NETSCAPE Navigator. So they go to ECMAScript and they said, hey, we want some of that JavaScript stuff, but we don't want any kind of legal conflict with Sun Microsystems because there's so much technology drama. It is amazing. You got to read the history to learn the drama. We don't want any issue with Sun Microsystems. We don't want any issues with NETSCAPE. So we'll call ours JScript. But we all know it was JavaScript, but it was the way that they used it. And they did do some particular things, different implementations, different from how NETSCAPE did, different from how other companies use JavaScript. And as a result, developers here today, 2020 and beyond, you have to go to a chart that lists all the imaginable browsers and all the different features of the language and see which ones work and which ones, because different companies, different institutions institute the language with their own dialect. That's why that happens. Well, there's some cool things down the road. Going back to my secondary computer, y'all give me just a second. Cool things coming down the road. We mentioned Node.js for the back end earlier. We have Ajax that comes online from Microsoft. That's a very awesome invention that they did, 1999. Ajax, great for making requests, handling APIs. Shortly after that, John Rizik gives us jQuery in 2006. He wasn't actually working at a company at the time. He was working with a thing called Basecamp, which was more like a conference, kind of like every year you go to the same conference, but he would go, he would build out this thing, and he eventually gave us jQuery, which gives awesome DOM manipulation. 2010, we get Backbone.js, Knockout.js. Those did not have very much of a foothold in the industry, so we're going to kind of skip over that. 2010 was a huge year. We get Google, who wants to be able to manage single-page applications in a much more efficient and scalable way, so they develop a thing called Angular.js. I'm going to skip. No, I'm not. React comes from Facebook in 2011. Meteor 2012, great for managing state. But 2014 is really neat. So look at 2010 and 2014. 2010, there's a guy working on the Angular project named Evan Yu. And there's a lot of the things that he's working on that he really, really loves. There's some other things that he's like, yeah, I wish we didn't put that, but that's okay. So by 2014, he says, I wonder if I could just take just the parts of Angular that I love and pull those out and make it a thing by itself. That's how you get Vue.js. 2015, you get Redux. 2016, you get GraphQL. 2017, WebAssembly, and on and on and on. Because JavaScript was written in a way when it was first written, when it was first given by Brandon, to be lightweight, to be almost like the Legos of the internet. And so it was very easy to take pieces of JavaScript and assemble them in different ways based on the use case that you have, which is why you have so many libraries and so many frameworks. Pretty much everything that these libraries and frameworks, and even Ajax isn't a library or a framework, it's really more like a set of techniques. But pretty much everything that these things can do can be done in vanilla JavaScript without them, but it's easier because they've done some of the vanilla JavaScript on the back end. All right, take a 2-second break, look at the chat. Awesome, awesome, awesome. Thank you all for awesome. Yeah, appreciate that. Nice. So this is something that you're never supposed to do in a chat or never supposed to do in a talk, but I'm going to do it anyway. I got this from a blog from Auth0, and I was reading the whole blog, and I saw this paragraph. I was like, this paragraph is literally the TLDR of my entire talk. So I'm throwing it in here. I'm going to read it to you. I don't care. Here we go. JavaScript was originally proposed as a scheme for the web. We talked about the scheme language earlier. Early on, it got Java-like syntax strapped on. First prototype was developed in a matter of weeks, 10 days actually. It suffered the perils of marketing, got 3 names in less than 2 years. Right? We went through those 3 names. It was then standardized and got a name that sounded like a skin disease, ECMAScript 262. After 3 successful releases, the 4th got caught up in development hell for almost 8 years. Fingers got pointed around, then by the sheer success of what? Ajax, from whom? Microsoft. The community got its act back together and development was resumed. Version 4, version 5, version 6, new air was breathed into JavaScript and the community is active as ever, right? Then you have things like Node.js, the V8 engine, and other projects that have brought JavaScript to places where it was never thought of before. And I didn't even mention ASM.js, WebAssembly, they're taking it even further. Now we have active proposals in different stages, all making JavaScript's future as bright as possible. It's been a long road full of bumps, but JavaScript is still one of the most successful languages ever. That's a testament in itself. Always bet on JavaScript. Before I hit this bibliography, which I know bibliographies don't typically go into web talks, but we've been talking about bibliography, so I thought I'd throw this in here, and I wanted to make sure you guys all go watch this YouTube video, Project Code Rush. It's on YouTube. It's about an hour long. It's about the critical days of NETSCAPE right before getting sold to AOL. That process by itself created instant millionaires, and what the culture was like and what engineering was like at that time. Again, we are so far separated from the metal and so many of the things we do. It's good to go back not only to some of the core languages, but the core companies that brought us to where we are. Watch that video. And then a lot of credit to all of these different blogs here. I got information from TechSpot, Auth0, Medium, Springboard, and of course, a whole bunch of Wikipedia. Speaking of NETSCAPE, I don't think this is even in my, this is even in my talk, but NETSCAPE, very interesting. They ended up getting sold to AOL. AOL took NETSCAPE to another level, did some amazing things with it. AOL eventually ends up selling it to Microsoft, who had no idea what to do with it. They knew it was popular, but they didn't know what to do with it. So it just kind of sat there. From Microsoft, it went to Facebook. And then from Facebook, it went to Verizon Media, where it's pretty much just a trademark today. So it died, but it died an honorable death. So I would love for you all to connect with me. Hopefully you've enjoyed this talk. If you find me on, you can find me on YouTube and Instagram as Coding Paths. I like talking about the different ways that there are to get into tech and the different paths that you can choose once you get here. Join me on any of those different places there. On LinkedIn, I'm just Lawrence Lockhart, the one that works at FedEx. There's only one. Twitter, LD Lockhart Jr. My tweets are kind of sporadic, so don't look for a lot, but I am on Twitter. And for sure, I would love everyone who sees this, join me on Code Connector. It is a meetup group. Obviously, we're in virtual mode right now. We talk mostly on Slack every day. If you go to codeconnector.io, there is a way to connect with us through the Slack channel and hang out with us. This is an organization that helped me to find my way when I was just getting started in tech, didn't know what I was doing, wasting a lot of time, and pretty much just lost. These guys and young ladies helped me out. And so that is why I am very much invested as a leader with this organization now. That's the end of my talk. Thank you all for hanging out with me today. And I hope you enjoy the rest of your Udacity Study Jam. Got one more message in the chat. Awesome, Big L. Thank you, Columbus. In a time vault. Yes, absolutely. What memories? Yep, all the memories.
Thank you. Good job.
Appreciate that.
Yeah, thank you.
Good to see y'all. Enjoy your next session. Appreciate all the love.